Okay, so today we're going to work on our final piece of factoring, which is how to factor and solve. And we've kind of touched on this throughout the chapter, but today we're really going to focus in on what does it mean, how do we do it, and just kind of pull all the pieces together. We are going to look at a new factor generator today, so you definitely want to open up this link below. We'll include the link in Schoology. That way you can just click on it or you can just type it in. But this is the factor calculator that you'll be using on assessments because the calculator soup one will not open inside of the lockdown browser. So when we work with this factor calculator, the way this one works, when I put the number in, so let's say I put in 150, I hit calculate. You can see that I have the factor pairs here. I have 75 and 2, 25 and 3, 5 and 5, and it also gives me the sets up here, 1 and 150, 2 and 75. So it gives them to me in a couple of different views. It's not the best vertical view, but it is one that will work for us. So 1 and 50, 1 and 150, 2 and 75, 3 and 50, 5 and 30, 6 and 25, 10 and 15. It also gives us the prime factors with a prime factor tree. To be able to enter another one, on this one, you have to hit factor calculator. Okay, so you don't go backwards, you just hit the factor calculator. It pulls back up to the regular screen, and I can hit 140 and see those factors. Some of you may not need this, but it is here if you need it. Remember, hit the factor calculator to go backwards, and make sure you open that today as we start our notes. Okay, so here we go. Here we go. So we've already looked at what does a quadratic look like. We know the quadratic is actually a parabola. Okay, we know it's the smile or the frown, or think about it as a U. That's pronounced parabola. And we know that there are two important points on the quadratic. Okay, they are called the roots or the zeros or the x-intercepts. You'll see them called all three things: roots, zeros, or x-intercepts. And that's literally what they are. They are the x-intercepts. They are where the graph is going to cross my x-axis. Okay, so this ordered pair would be -2, 0. And this ordered pair would be 0, 0. Okay, and when we are solving a quadratic function to find the roots, okay, or solving by factoring, we are looking for these numbers. Okay, we're looking for those numbers. We're looking for the roots. So to be able to do that, I know that we can have either 1, 2, or none as far as roots go. Okay, so either it can touch it once, or it can touch it twice. And most of them are going to touch twice, which means I need to have two equations. Okay, so the nice part is when I see something like this, it's pretty easy to solve. Okay, so I know that the 3x has to equal 0, and I know that the x plus 2 has to equal 0. So anytime I'm solving for the roots or the zeros, I need to make sure that it's equal to 0. Whatever the expression is equal to 0, and I have to solve. Okay, so I have 3x equals 0. Well, that's pretty easy. Divide by 3, x is 0. This one, subtract the 2, x is -2. So if I take a look at my numbers, I see that I have a -2 here and a 0 here. So what I just did was I found those x values of my ordered pairs. So that means that the 0 would go in the first spot, and the second number is always going to be 0 because it's saying y equals 0. Okay, so I'm replacing the 0 here. Okay, I'm replacing the 0 there. So this one would be -2, 0. Okay, let's look at this one. So again, this one is already factored. So I know that I have two equations: x minus 2 equals 0, x plus 5 equals 0. And the nice part is solving these really doesn't take much effort, and I wouldn't expect to see you showing work on these. I would expect you to be able to just identify the solution, because you know that you have to do the opposite. So this ordered pair would be 2, 0, and this ordered pair would be -5, 0. And if I take a look at my quadratic, I see, and these are counting by twos. Okay, I've got 1 at 2, and I've got one at, whoops, let's get to the right spot here. Here's my x-axis up here. I've got one at 2, and I've got one at -5. Okay, so there is x equals the -5, and here is x equals 2. Now, I also know that this is positive, okay? So I know it's a smile, not a frown, which means that a is positive on my standard form because there's no negatives in front of this function. Okay, so now let's take it the full way. Let's factor it, solve it, and kind of sketch a graph. Okay, so the first thing I want to see is I see that this is positive, so I know that it's going to be a smile. Okay, and I know I have x squared minus 49, so if I think about that, that's difference of squares. I know I need -49 and 0, so that's -7, +7. I know those are perfect squares. And I can certainly do the box if I need to, where I have the x squared minus 49 minus 7x plus 7x. I can do that. But remember, when we're working with perfect squares, we know that they always factor into a plus and a minus and the root or the base number of that square. Okay, the root or the base number of that square. And we know that the root or base of 49 is 7. Okay, so this is equal to 0. So I know I have x plus 7 equals 0, and I have x minus 7 equals 0. So x is going to equal 7, x equals -7. And I will sometimes see this written as x equals positive -7 because it's the same number, just the positive and a negative. So if I was to sketch this, I would put a point at 7, and I would put a point at -7, and I know that I am sketching a smile because a is positive. And I don't know how far down it goes yet. We'll learn that next chapter. But for our purposes today, it's fine to just put your 2 points and draw yourself a smile. Okay, let's see if we can get this one figured out. So we've got 3p squared minus 2p minus 15. So this one we're going to need to go through our steps. We've got a -15 and a -2. So that's going to give me a -5 and a +3. Remember, for those of you who are struggling on how to do that, I'm going to put in a -15. I'm going to calculate. Oops, I guess this one will only take positive numbers, which is fine. So hit calculate, and I see that I have 1, 3, 5, and 15. And the only way that I can get 2 is with this 3 and 5. So if I use the box method, I have 3x squared, my minus 15, minus 5x, plus 3x. This one's going to be a +3, and an x, a 3x, and a -5. So I have two factors, 3x minus 5 and x plus 3. Well, this one's pretty easy. I know that's x equals -3. So I know that I have 1 point at -3. And it's perfectly fine to come up with decimals when you're finding roots or zeros. So this one is going to be a decimal. So 3x minus 5 equals 0. 3x equals 5. So if I divide by 3, 5 divided by 3 is going to give me 1.7 if I round it off, so 1.666. And I can go ahead and plot that point. So 1.7 is going to be closer to the 2. And again, I know that this is a smile, not a frown, because the a, which is 3, is positive. Okay, so why don't you go ahead and hit pause for a second and see if you can solve these two. And we're going to kind of sketch ourselves a little graph here also of the parabolas. Let's make that a little bit bigger. So go ahead and solve these two. Get me some answers real quick. Get me a quick sketch. Okay, let's see how you did. Well, obviously I'm adding 3, so x is 3. I'm subtracting 5, so x is -5. So at 3, I have a point. At -5, I have a point. And again, it's going to be a smile because I don't see any negatives. on my x's. So my a term would be positive. Okay, this one, if I add my 3, 2x equals 3. X is going to equal 3 over 2, which is 1.5. And this one, I subtract my 5. So 2x equals negative 5. X is going to equal negative 2.5. So negative 2.5 is between 2 and 3, and 1.5 is between 1 and 2. And again, it is a smile, okay? And remember, when we are solving quadratics, they can have 2 roots, they can have 1 root, or they can have no roots, okay? Or zeros. And what that means is I can draw a quadratic and it's going to touch twice. That's the one that we see the most often. I can also draw it and it's going to touch just once. So its vertex is going to touch. Or I can draw it and it's not going to touch at all. So for example, if I draw a quadratic and let's say it's negative and it's here, it does not touch, okay? So this one has 2, this one has 1, and this one has 0. And we will come up with some that have 0. We'll have 0 roots. And those are unique ones, but they do happen. Okay, so let's take a look at now one where we have to kind of go through the full process, okay? So I want you to start by factoring this. So remember, the first thing we look for is always our GCF. So when I think about 30, 27, and 6, I know that I can take out a 3. So let's take out a 3. Okay, let's take out a 3. And I'm going to go ahead and write that here. So if I divide that by 3, I come up with 10x squared minus 9x plus 2. So go ahead and use your Xbox method to be able to find those factors. And let's go ahead and see if we can get this solved. So hit pause and see what you can do with it. Okay, so I know that I have a positive 20 because I take a times c and I have my negative 9. So factors of 20, I have 1 and 20, 2 and 10, 4 and 5, and I know I can get 9 there. And remember, this is a negative 9, so negative 5, negative 4, I have to add to multiply to get that positive 20, so I'm good because a negative times a negative is positive. So again, when we write this, we're going to use this equation, not the 3. So 10x squared plus 2, the negative 5x, the negative 4x, and let's pull our negative out. So this one's going to be a negative 1 because there's no common factor between 5 and 2. And here I can take out a 2x, and here I can take out a 5x, and here I have a negative 2. So let's go ahead and kind of check this to make sure that we're right. So check your first terms, last terms, and your middle terms. So there's 10x squared, there's a positive 2, and if I multiply here, that's a, oops, I just did that one. If I multiply the outers and the inners, that is a negative 4x and a negative 5x. So that would give me my negative 9, which I need. So 2x minus 1 and 5x minus 2. Okay, go ahead and hit pause, solve these, and sketch your solution. All right, so 2x minus 1 equals 0. 5x minus 2 equals 0. X is going to equal 2 over 5, okay, which is 0.4. And 2x equals 1, so x is going to equal 1/2. So if I'm sketching this, so positive 1/2 is going to be between 0 and 1. And let's go ahead and make this a little bit bigger because we got 2 positive numbers. So I'm going to go ahead and make this 0.5 and this 1. So this is a pretty narrow quadratic. So I'm going to go ahead and spread it out a little bit so we can see it. So 1/2 would be here. 0.4 is going to be close to the 0.5. This is a very skinny quadratic because those two roots are very close together. And again, I know it's positive because my a is positive. Now, some of you may be going, hey, what's up with the 3? Well, notice there's no variable there. Okay, so if there is no variable in my GCF, I'm just going to ignore that 3. It's technically there, but it is not a solution to my quadratic. If there was a variable there, totally different story. Okay, now let's take a look at what we call the square root property. Okay, and this is another way to solve quadratics. And sometimes we will see them written like this, x squared equals 25, and we can use the square root property to solve it to find our roots. You can also factor. We get the same answers, but sometimes this is actually faster, okay? So if I have x squared minus 25, I know that the opposite of a square is a square root. So if I take the square root of x squared, I get x. And if I take the square root of 25, I know I can get a positive or negative 5. So we have to remember that there's two solutions. There's a positive and a negative. Okay, there's a positive and a negative. So my steps are, I need to get x equals by itself, take the square root. Okay, so x equals alone, take the root of both sides, and then finish solving. Okay, finish solving. So let's go ahead and take a look at this first one. So x squared minus 16. So the first thing I'm going to do is move my 16. So I have x squared equals 16. Then I'm going to take the square root of both sides. Well, this one I know is x. I know I have to have a plus minus. Well, the perfect square of 16. So the root of 16. And if you are struggling remembering how to do that, so let's take our Desmos calculator. I'm going to put a 16 in here. There's my base. The base is 4. You're looking for the base numbers. Okay, you're looking for the base numbers. So the answer is positive or negative 4, which means my factors would be x minus 4, x plus 4, which makes sense because that's a perfect square. Okay, that's a perfect square. All right, now this next one's a little bit harder because there's actually other numbers inside of here. So this one gets a little bit messier, but it's still not hard. So we're going to follow the same process. We've got x squared, x alone. So that means this part's alone. The power of 2 is alone. And we are going to take the square root of both sides. Okay, so we have y minus 6, because that's what's left when I take the square root, because these two cancel out. And I have it equaling positive and negative 9. Okay, positive and negative 9, because the square root of 81 is 9. So this leads to two equations. Y minus 6 equals the positive 9. Y minus 6 equals the negative 9. And then I'm going to solve. So I'm going to add my 6, and I get y equals 15. If I add my 6 here, I get y equals negative 3. Okay, so if I was to sketch that, I've got negative 3 here, and I've got negative 50 or positive 15 way over here. Here's my quadratic. Okay, so this ordered pair is negative 3, 0, and this one is 15, 0. Okay, 15, 0. So if I was to actually write the factors, remember it's the opposite. This one would be y minus 15, and this one would be y plus 3. Okay, go ahead and hit pause. See what you can do with these two. These are going to come up to decimals. Okay, and we're going to look at them in terms of radicals and decimals. So let me run you through the first one, then you can try the second one. So the first thing, again, is we're going to take our square roots, because we've got our squares by themselves. So z plus 3 is equal to positive negative square root of 26. Now 26 does not have a perfect square, okay? So we need to figure out what that value actually is. So let's take the square root of 26, and I'm going to get 5.09. Let's round that off to 5.1. So positive negative 5.1. Now we will see this written two different ways. We'll see this written as a decimal, and we'll also see this written in radical form. So if I am looking at the decimal, I would have z plus 3 equals the positive 5.1, and z plus 3 equals the negative 5.1. So z would equal 2.1, and z would equal negative 8.1. Okay, so that is the decimal form. If I am looking at the radical form, then I'm actually going to leave the plus minus alone. So z plus 3 is equal to a positive square root of 26, and z plus 3 equals a negative square root of 26. So when I move my 3, it ends up being negative. So the answer is z is equal to negative 3 plus the square root of 26, and negative 3 minus the square root of 26. Okay, and here's how we write it. Z is equal to so 3, oops, we need a negative 3, equals a negative 3 plus or minus the square root of 26. So this would be the more likely way that we're going to see it. Okay, and we will eventually break down the 26 in one of our next chapters to be simplified if it can. The 26 is actually not going to go down any farther. But so we can either see it as decimals or we can see it as radical. Usually the radical is going to show up a little bit more often. Okay, hit pause. See what you can do with this next one. Let's go ahead and find it in decimal form and in radical form. All right, so let's see what we did, how we did. So square root of both sides. X plus 6 equals the positive and negative square root of 12. Okay, and I'm going to go ahead and just write my inequality or my equation here by just subtracting the 6. Okay, so I have x equals negative 6 plus or minus the square root of 12. So there is my radical form of that equation. And to be able to get the decimal, I'm going to take the square root of 12, which is 3.5. So x equals negative 6 plus or minus 3.5. And I'm going to break that up. So negative 6 plus 3.5, negative 6 minus 3.5. So I know that I have an answer of x equals negative 2.5 and x equals negative 9.5. And if I'm going to sketch that, I can sketch it from here. So negative 2.5, negative 9.5. It's much easier to sketch it from the decimals than it is from the radical. Okay, so let's see how you can do on your homework today. Reach out to us if you're struggling. We do have a concept check and a test coming up, so you do need to kind of pull all this stuff together. Factoring is a pretty key component to what we need to learn in this semester. So if you're struggling, please reach out to us. And remember, we are using this new factor generator today on your homework, so you get used to it. And remember, you have to hit factor calculator to go backwards. So that will be embedded into your assignment today. So reach out to us if you are struggling, and we'll see you tomorrow.